Hello students, hope you are doing well. In this video we are going to discuss route summarization of Unit 5, designing IP addressing in the network and selecting routing protocol for the subject Enterprise Network Design of B7 Semester IT University of Mumbai. In this lecture we will discuss route summarization. Under this, the benefit of route summarization, recommended practice summarize at the distribution layer, and passive interfaces for IGP at the access layer. Benefits of route summarization. So it includes a large flat network is not scalable because routing traffic consumes considerable network resources. When a network change occurs, it is propagated throughout the network, which require processing time for route recomputation and bandwidth to propagate routing update. A network hierarchy can reduce both routing traffic and unnecessary route recomputation. To accomplish this, the network must be divided into areas that enable route summarization. Okay, so this we need to divide the area where we need route summarization. With summarization in place is a route flap. This is standard terminology. A route flap, a route that goes down and up continuously, that occurs in one network area does not influence routing in other area. Okay, then instabilities are isolated and convergence is improved, thereby reducing the amount of routing traffic, the size of routing table, and the required memory and processing power for routing. Summarization is configured manually or occurs automatically at the major network boundaries in some routing protocols. Being able to summarize requires a well-planned underlying IP address design. So this is very important point. Okay, so this is how the benefits of route summarization means what are the different benefits and what is the effect of particular route failure or route flapping. So this is discussed here. Standard practice summarize at the distribution layer. So this is diagram of distribution layer and multi-level switches are there, and this whole diagram summary routes only, no queries for individual subnet and rest of the network. So it is recommended practice to configure summarization in a large network from the distribution layer towards the core. The distribution layer should summarize all networks on all interfaces towards the campus core. Okay, so towards the campus core, we need to summarize the network. WAN connectivity and remote access points should be summarized towards the core. Like remote subnet could be summarized into major network, and only those major network would be advertised to the core. Implementing summarization at distribution layer optimizes convergence process. For example, if a link to an access layer device goes down, return traffic to that device is dropped at the distribution layer until the routing protocol converges. Summarizing also limits the number of peers that an EIGRP router must query or the number of LSA that an OSPF router must process, which also reduces the convergence time. Okay. Core routers that receives two routes for a network install the more specific route in the routing table. Therefore, summary routes for primary link must use a longer subnet mask. Recommended practice for passive interface for IGP at the access layer. After recommended practice is to limit unnecessary peering across the network access layer. In this figure, the distribution multi-layer switches are directly connected to each other and are two interconnected with three access layer switches. Okay, so these are the access layer switches, and these are multi-layer switches. So these two are connected to these three. And here in this figure, the distribution multi-layer switches are directly connected to each other and are also interconnected with three access layer switches, each having four virtual LANs by default. Okay. The distribution layer devices send routing updates and attempt to peer with the remote distribution layer devices across the link from the access switches on every virtual LAN. Having the distribution switches from neighbor relationship over these 12 access layer connections provide no benefit and waste resources, including CPU, processing time, and memory. Therefore, the interfaces on the distribution layer devices towards access layer device are configured as passive interfaces under the routing protocol configuration. This surpasses the advertisement of routing updates for the routing protocol on those interfaces. Now come to configuring passive interfaces. How to configure passive interfaces? In a network that has many virtual LAN interfaces on distribution layer routers, configuring each interface on as a passive interface could result in many commands. To ease the configuration burden, Cisco iOS 12.0 introduces passive interface default command. Okay, so the command is passive interface default, which makes all interfaces passive. This command can be used in conjunction with no passive interface. No passive interface. So to run the routing protocol on only the interfaces from distribution layer devices to the core layer devices, this minimizing the configuration required. Okay, so let us now summarize the chapter. In this lecture, we have covered the benefit of root summarization recommended practice, summarize at distribution layer recommended practice, passive interface for IGP at the access layer. In this unit, we have covered static versus dynamic routing, interior versus exterior gateway routing protocol, distance vector versus link state, routing protocol matrix, routing protocol convergence, flat versus hierarchical routing, EIGRP, a Cisco proprietary routing protocol that includes a topology table for maintaining all routes received from its neighbors. The best of these routes are put in the routing table. OSPF, an open standard protocol that was developed to overcome the limitations of RIP. Integrated ISIS, a routing protocol designed for iOS protocol suite and adopted for all IP. BGP, an exterior routing protocol primarily used for inter-AS routing, autonomous system routing. Route redistribution used in the network running multiple routing protocol, and route filtering to prevent the advertisement of certain routes through the routing domain. Route summarization to represent a series of routes by a single summary address. So these are the content of this unit. There are many questions. Let us see some of them. In what situation could a static routing be preferred over dynamic routing? So it is given in first part of the video. What do dynamic protocols? What does do? Okay, dynamic routing protocol do. Which type of routing protocol is used for interconnecting autonomous system? It is also known as AS. Do IGP or EGPs typically converge faster? What is BGP's multi-homing? How do distance vector and link state routing protocol differ? What are triggered update? What parameters do following routing protocol use in their matrix calculation by default? And these protocols are RIP, IGRP, OSPF, BGP, ISIS. One table is shown in previous slide. What is convergence? So synchronization, very important thing. Synchronization is synchronization with respect to all route. How does the speed of convergence affect the network? Okay, So faster convergence is very important. What is an advantage of hierarchical network versus flat network? So you need to go for previous slides to answer all these questions. In next video, we will start Unit 6 Software Defined Network. This is not part of Cisco's proprietary protocol. This is additional reading. Okay, so it is given in your Unit 6. So we will discuss software defined network, and it is latest technology and coming under IoT, Internet of Things. So thank you very much. Bye bye for now. Have a nice day. Have a nice time.